Hi, so today we're going to learn a little bit information on the elements. This can be taken from the periodic table. So the first thing that you see is the symbol. Symbol is represented by one or two letters that have to do with the name of the element, and this could be found in different languages. So for example, silver, the symbol is Ag, and it's because the name of the element is argentum in Latin. We also have here the atomic number. This is represented by the letter Z, and it has to do with the number of protons found in an element. If that element is neutral, then the number of protons will be equivalent to the number of electrons. But if that element is ionized, meaning that it has lost or won electrons, then the number of protons and electrons will differ. That's why the atomic number is always associated to the number of protons. Down here, what you see is the atomic mass. This is represented by the letter A, and it is basically the sum of the protons and neutrons that are found in the nucleus of an element or atom. Now, this atomic mass, if you see, has decimals, and this has to do with the fact that it's an average. What they do is they average the neutrons found in different isotopes. Isotopes are elements found in Earth that have a different number of neutrons, but the number of protons and electrons are the same. So that's why you will see numbers with decimals, but remember that neutrons are particles, so we usually represent them with a whole number. Now, if we are strict, the number would be 20.078 units, but since we know neutrons are particles, we cannot have decimals to represent them. That's why we'll leave it in 20. Okay, so let's take a look at this example in which we have an ionized element. This is sodium, it belongs to family 1, and we have a +1 here, indicating that sodium has lost 1 electron, right? So we said that Z represents the number of protons, and it's this given number here, so Z will be equivalent to 11, and this will indicate the number of protons in my element. In the case of electrons, we have a trick here because the initial number of electrons was 11, but we know that because of the charge is +1, this means that my element has lost 1 electron. Therefore, my number would be 10 and not 11 as the original element. Now, in A, which is the atomic mass, we have 22.989769 units. So when we want to get the neutrons, what we do is A minus Z. Remember that the neutrons depend on the isotopes given by the elements. So in this case, my neutrons would be equivalent to 22.989769 minus 11. Now, don't forget to round it up because neutrons are particles, so we cannot have decimals representing it, okay? So this would evidently be 11.989769. So we round it up to 12. And that's all.